Okay, so looking ahead, our next and final presentation for this section of the DNSSEC and security workshop is from also from ISC, from Petr Špaček, DELEG, and what does this mean for DNSSEC? Over to you, Petr.
Thank you very much. Hello, everyone. We are in the section talking about exciting things like post-quantum, and this is going to be exciting for a different reason. It's not related to cryptography per se, but it's more targeted on simplifying DNS management, including DNSSEC. So let's have a look. So how does the clicker work? Does it? What did you do with it? Okay, now it works. Disclaimer, we are going to talk about work in progress. It's very much work in progress. Nothing is set in stone. It's more like, the substance is more like a smoke. So everything I will say might change tomorrow. Don't fixate on like little details on slides. Let's talk more about the concepts. So first, why is IETF touching DNS? Roughly 3 years ago, a bunch of DNS experts came together here in Prague at IETF meeting, and we've tried to come up with problems and limitations, pain points in the existing DNS protocol and DNSSEC as well. And this was kind of wild idea affair where we ended up with literally 7 pages of bullet points from top to the bottom, what could be improved in the DNS, and quite obviously that's untractable. So eventually, the group identified the underlying problem, which was common for maybe half of the points, and that was the lack of the extensibility or like fixed structure at the DNS delegation point. These slides, which will be for sure available to you, have clickable links in the slides, so you can go and see the video and slides from that time if you're interested in historical details and how we got here. But for today, let's have a look at the DNS delegation, how it looks in the existing DNS. Nothing new on this slide. So in the first 2 lines, we have the traditional DNS delegation where we delegate the name DOM to name server 1, and the name server 1 is inside the domain we are delegating. And for that reason, we need a so-called glue record that's on the second line. So we have the delegation NS record, glue record, that's the quad A in the middle. So as of today, we have a problem because there is no signature over this. So on the first contact with that authoritative server or with that zone, the resolver practically has to do leap of faith at first try and only then potentially validate. And second trouble is that this record structure is not extensible. It's just on the right-hand side, we have just a name and IP address. And while encoding data into IP address, that would be really ugly. And encoding some meaning into names, while technically possible, it doesn't really get us anything because the name is not signed. So we cannot really trust the information anyway. With introduction of DNSSEC, we've got slight improvement because we've got the DS record, the delegation signer, which is signed, which is very important. But the structure of the DS record as of today is basically a fixed thing. It was designed to serve single purpose, to contain a hash of a public key and nothing else. So even though maybe technically we would be able to, with sufficient force, put another information there, that was discussed in IETF at length in the DPRIVE working group and refused after like 5 years of trying to come up with a scheme how to make it work. So let's not do that. Let's try to design something which would actually work, wouldn't be terrible hack, and would be future-proof. To do that, the IETF eventually established working group with the acronym DELEG, and the working group limited itself with set bounds for itself. You can see them on the slide, and basically we can say that from ordinary user, nothing will change. So besides other things, the namespace, the idea that the DNS is a tree of names, that's not changing. The idea of the zones where, for example, a root zone delegates to a TLD, and then a TLD can delegate down to the second level domains and so on and so on. That's not going to change either. The data model where the client asks for a name and type combination and gets back a set of records, that's also not going to change. So these are the limits the working group set for itself, and obviously it has to be compatible with the existing DNS, otherwise we will not get anywhere. So these are the limits for the new protocol. So what can we do about it? Again, I will repeat this a couple more times. What you are going to see on the next slides is work in progress. You can see it's version 00 in IETF. So there is literally nothing set in stone. So let's focus on the concepts here. The new delegation mechanism, just to make it more confusing, is also called DELEG, the same as the working group, because the working group is dedicated only for that purpose and nothing else. It's currently proposed in two different modes of operation. The first is called direct mode, and that's essentially replacement for NS records and glue records with some improvements. We will get into details in a minute. And the second mode of operation is called include, and that's essentially adding layer of indirection into the delegation chain. And that's the interesting part where we can actually do new magic with DNSSEC and simplify DNSSEC management, hopefully. So let's have a look at the example. This is the very basic DELEG direct record or DELEG record in the direct mode. And you can see on the first 3 lines that's DELEG record and its signature. And on the bottom of the slide, we have the NS record and glue record. So in other words, the delegation in existing DNS as of today. And you can see for yourself that these are essentially the same. It's exactly the same information. It's name of the server and IP address. So same information, but put in different record. And the difference is that first, glue record, or so the IP address and the name are together in one piece. So they are one unit of information which gets shipped around in the DNS. And second major difference is that the DELEG in the direct mode is actually signed, which is very important difference from the existing system. And it is signed by the parent zone. So it's essentially the same as the DS record today. The DS record today is signed by the parent, and for the DELEG, it is proposed to sign it at the parent as well. So that's same mechanism. And another difference is that the DELEG record as proposed doesn't have a copy of the record in the child zone. So it exists only on the delegation side, in the parent zone, but the child doesn't have to copy the record or shouldn't copy at all. And that means that there is no way how it can get this desynchronized between parent and child, which happens very often with the existing system, and it is causing trouble in the resolver operation. So we're getting rid of that problem as a side effect of introducing DELEG. Okay, so, but just copy pasting or like getting the same information in a little bit different form maybe is not enough of improvement. But what's more important here is that the DELEG record is extensible. It is built to be extensible. So on the right-hand side, you can see that there is additional parameter transport equals DOT. That's just an example, but it demonstrates that, for example, we could say in the delegation that this authoritative server can be reached using DNS over TLS. For example, we can introduce anything else because it's universal key equals value mechanism, so we can put anything we need in down the future 10, 15, 50 years from now. Again, this record is going to be signed by the parent zone, so the resolver can trust the extensible parameters, the additional information, without the leap of faith, which is very important detail and difference from what we have today. That was for the direct mode, which is reasonably easy to understand, but the include mode is, as we've said before, adding a layer of indirection, and that's what actually allows us to simplify the management here. In this example, we have one domain, DOM, which is using DELEG record in include mode, and on the right-hand side of this record, we have a pointer to different place in DNS. So on the right-hand side, in traditional NS record, we have name of a name server. That's how it works today. But with DELEG include, we are making conceptual change because the right-hand side is not a name of a server, but it's a name somewhere else in the tree, which then contains the further information like names of servers and so on and so on. So here we have the indirection to actually two different operators for single domain. So single domain is hosted by two different companies, which do the technical work of making it work on the internet. And the delegation in the parent zone contains a pointer. So here, one pointer pointing to subtree used by operator 1, and second pointer, second DELEG include record pointing to different place for operator 2. And the operator 1 in this example is advertising one name server using transport, let's say DNS over port 53, the traditional protocol. And the operator 2 is actually advertising one server NS5, which is available using DNS over TLS. So, and the nice thing here is that the domain holder doesn't have to deal with the technical details. The domain holder just puts in the pointer to an operator, and that's it. Then we can say that, in 2 years, the operator 1 decides to set up a new name server or a new Anycast cloud and start serving domains they provide for their customers using DNS over TLS as well. So they just introduce new line onto the left bottom end of this slide and say like NS52 transport equals DOT, and that's it. They don't have to go and modify the delegation for every single customer domain because the delegation now contains just a pointer. So they don't have to go into the parent zone and change everything. And of course, the extensibility is in the include and DELEG records, direct records as well. So we are not limited to the transports in the example, but we can do whatever we need to in future with the extra parameters. So to sum it up, the DELEG record in the include mode kind of removes the need to copy-paste the NS records, because today, if someone registers a domain, they will get a bunch of NS records, and we ask the domain holder, please copy this and put it into your registry system, assuming the provider is not actually a registrar. But with this include mechanism, the domain holder basically needs a single line and doesn't ever need to change it until they migrate to different operator. And at the same time, it removes the need for the operator or the tension where the operator would like to update the technical data, but the operator typically cannot because the operator is not authorized to touch the parent zone. But now they don't have to because the parent zone doesn't contain the technical data anymore. Okay, so this is DNSSEC workshop. So where is DNSSEC in it? We are talking just about the delegations, but we are getting to it finally. Again, I will repeat the warning one more time. What we are going to see doesn't exist at all. It's not even in the 0.0 version of the draft. There are two slightly different proposals, but conceptually we're in the working group talking about the same idea. The working group is really like hot on the idea of like being done with the delegation and moving to improving DNSSEC, but we're not there yet. IETF works at its own speed. So roughly, conceptually, the idea is the same as a DELEG in the include mode. It's basically adding layer of indirection into the DNSSEC chain of trust, and that would allow us to do simplifications in the DNSSEC management. Essentially, today, with the existing DS record, the operator or whoever actually signs the domain produces a record with a hash, and the domain holder somehow has to copy that record and put it into the parent zone and hope that they didn't make any typo or mistake. And that's kind of tedious, and as we see on the statistics presented a couple of minutes before, the uptake is pretty bad. So let's try to simplify this operation. Here we have the idea of the indirection in the DNSSEC chain of trust. Just conceptually, again, don't fixate on like the specific syntax. But essentially here, we have a domain which points to an operator using DELEG include record. And the difference here is that the DELEG include record contains additional parameter. Here, for simplicity, I've called it trust equals yes. And that's an explicit signal from the domain holder, which says, I trust this operator to handle the DNSSEC for me from beginning to end, everything. I don't want to do with it anything with it by hand. The operator is trusted to do everything for me. That's it. And now the resolver, when it's chasing that delegation information, it will get the pointer to the, let's say, config subtree of that particular operator. And the operator can specify, for example, that the DNS key used to sign this particular domain is named key.operator1.test, for example. And then the resolver will get the DNS key and validate it as usual. So here, the conceptual change again is that the domain holder doesn't deal with the cryptographic material at all. The domain holder only points to an operator and indicates an explicit intent to trust that operator to deal with DNSSEC, and that's it. So hopefully, the idea is that the domain holders can set this up once, and even if that particular operator is not doing DNSSEC signing at the moment, it doesn't change anything, because at the moment when the operator decides to sign zones for their customers, they don't have to change the delegation anymore, because the delegation in the parent zone contains just the pointer to operator, and then the operator at some point in the future can introduce the DNS key, sign the zone, and that's it. And it doesn't require talking to the domain holder or changing anything in the parent zone. So it's explicit authorization for the operator to change stuff. Obviously, it's optional, right? If you don't want to trust that particular operator, perhaps don't serve the domain with them. But if you decide to do so anyway, because you are offline signing and they are just doing the secondary service for you, that's entirely possible. You don't have to trust it, but it would be a new possibility. And as a side effect of this, it kind of accidentally simplifies the multi-signer scenario, because now the signers, that means like two different organizations or multiple different organizations, which independently sign the zones, suddenly don't have to coordinate between each other anymore, because the resolver, when it's chasing the delegation, will get the information that this set of servers is supposed to use this key to sign the zone, and this other set of servers from operator number 2 is using this other key. So the resolver can exactly match the key and the information obtained from that particular set of servers and do the validation using the matching key. So the signers don't have to coordinate, they can use this joint set of algorithms and so on and so on. And the security properties of this are essentially the same as for CNAME today. So if you have sign zone and CNAME in it, which points to a different sign zone, that's essentially the same, because the resolver has to walk the chain of trust like up and down again to like establish the link between the two. So that's essentially the same. Again, this does not exist. The reason why I'm here is to attract your attention. The IETF is working on it, but it would be very good if it was broad audience of people who actually operate stuff and have vested interests in the development of the protocol, or down the road operating it, because that's where the IETF typically lacks the participants. So if you are an operator or have any interest in this, please come forward. Here's a bunch of links for you. The first is to the working group itself. Second is the mailing list. It's not really high traffic. Even if you just want to lurk and see what happens, you don't have to be afraid of, flood of emails. It's like a couple of emails a week. It's not terrible as some other places in IETF. Third link is actual draft of the protocol, which is very brief, but again, it will change. Please talk on the mailing list. And the last link on the slide is actually an invitation for the interim meeting, which will happen next week. It's open to anyone, so please join us. Thank you for your attention.
Thank you very much. That was very, very interesting. I mean, myself, I work both as a a registrar, and if I'm not hosting the DNS, then every night I go and check to see if the name servers of the other people have been updated or not or something, to make sure that the information I've got is correct and I can pass it on to the registry. But I also wear a registry hat for a couple of second level domains in South Africa. And I do similar stuff there, working to make sure that the information that I got actually is coherent. But if it's sort of given to me or presented like this, that would make my life a lot easier. Anyway, I do see a question from Victor. So Victor, over to you, please.
Sure. I'm asking two questions really, but I'll ask the second one. I think it's more interesting. With the trust model for DNSSEC, what happens to a resolver that's behind a forwarder? Because it doesn't necessarily know which authoritative server the answers are coming from, and so it doesn't necessarily know which signatures to apply. Has that been considered, and is there a design for that?
Yeah, sure. I think that the best answer is go to the mailing list and praise it. But I think that in principle it's not a problem, because what happens inside the resolver is that the resolver constructs the union of the keys which are authorized to sign the zone. So it can look through the union and see whether the key matches, any of the key matches.
All right. Okay, got it.
To your second question, the more interesting one, as you said.
Yeah, no, that was the second one. The first one is, are the configs intended to be one config per zone, or are they potentially intended to be shared so that maybe multiple zones will end up getting the same signing key?
Up to the operator. I don't see a reason why the protocol should prescribe either or.
So it might encourage some sharing of keys, and if our crypto is good enough, shouldn't be a problem, right? That's the view.
Well, I'm not a cryptographer, so I don't have a say in that. But if I look at the operations today, we have a couple of million zones signed with the same key with online signing. So I don't think that we are making it any worse.
Okay.
There is a question in the room.
Yes, David Lawrence. I'm a co-proponent of DELEG, and I just wanted to mention for the ICANN community that the registries and registrars are certainly being taken into account in the rest of outside the DELEG working group. As many of you know, the EPP working group in the IETF deals with the provisioning protocol, and RPP has recently spun up for a RESTful state provisioning protocol. And both of them will be working on, as the DELEG work itself progresses and something gets identified in the DNS protocol, making the appropriate changes to the provisioning protocols will be then within scope of the IETF to be able to get that data into the registries.
Thank you for that clarification. Do we have any other questions coming from the room or statements?
Yeah, it seems we have.
Rob Golding. So just for those of us that struggle a little bit with things like this, if I want to send you an email right now, I will look up your domain to find out its name servers, to question those name servers, to get an MX record to send you an email. This to me seems like you're suggesting, instead of me asking for the name servers, I'm going to ask for a pointer to a different zone, which I'm going to have to look up name servers for and then retrieve in order to be able to get a config file in order to be able to find something out. Isn't that just name servers that point to other name servers? How is that different to what we have now?
Yeah, it is name servers pointing to different name servers. You are correct. And it's not fundamentally different from what happens today, because today if you send email to example.com, you need to get the mail servers from that domain, right? And it might happen very easily that you will get delegation which says example.com and name server name is ns55.someoperator.net, and that means that you have to go and chase net name servers and then some other operator domain and then the NS name. So even though it doesn't seem like it at the first glance, this very nested and recursive nature of getting to the name server name and IP address is happening today. We are just making it more explicit. That's about it.
I should add, it's not just like one top-level domain. So some names has like .net, .it, .com, and .base, and you need to chase all of them, and it just explodes very quickly. And difference with DELEG is that right now there's a like hierarchy of the priorities of the name servers. So there's a parent name servers and the child name servers, and they could be completely different right now. And the DELEG just removes this from the DNS, because the inconsistency is quite common in DNS, that the child NS and the parent NS are different, or some are same and there's a different subset or superset at some level, and it happens all the time.
There's one more question in the room.
Yes, thank you. Christian Hesselman, SIDN. I was wondering if I'm still struggling a little bit how to classify this working group in terms of, is this an incremental improvement of the DNS, or are we talking about a fundamental shift? And if it's the latter, what will be the implications?
Well, that's a philosophical question, right?
It's what?
That's a philosophical question, right?
Well, I'm asking for your opinion, so you can philosophize if you want.
Well, I think it enables development because right now we are kind of stuck, because for example, we cannot change the VAR protocol because there is no version number. So I don't see it as a revolution. I see it as a incremental change.
But it will provide quite a few advantages to the industry, right? Improved, I mean, ease of use, making things more explicit and all these kinds of things.
Sure. I mean, that's the reason why we are trying to do that, because the DPRIVE working group in ITF tried to come up with the privacy, like secure transports between all the pieces in the DNS ecosystem, including resolvers and authoritative servers. And after 5 years of trying, they ultimately failed because they just couldn't get the additional information to the parent zone, which is what we are trying to solve here with the DELEG. And that's only one of the use cases, obviously, right?
Okay, thank you.
So if this is a philosophy question, I would say this is an incremental update that allows the revolution.
Okay, I'll buy that. Thank you.
Mark, Russ Mundy has his hand raised. Russ?
Go for it, Russ.
Thanks. And Petr, thank you so much for the presentation. It was really informative. I've heard a bit about DELEG, but have not had the time to kind of follow what they're trying to do. So this was very helpful for me. Thank you. The question that I had was primarily related to the work that's going on in terms of the second half of the workshop today that Steve Crocker will be sharing for the multi-signer and incorporating the participation of DNS operators and trying to make the whole effort of keeping DNS zones signed during various types of transitions. Are the discussions involving any overlap, particularly of people who may be working on both types of things? So, lessons learned from one can be fed into to DELEG. Thank you.
I think I can say only in generic terms that certainly the working group has the multi-signer concept use case in mind, and it was definitely discussed when we sanity checked that the current proposal can support the multi-signer. Even though it's not in the 0.0 version of the draft, we are certainly trying to come up with mechanism which will work for multi-signer, if that's what you mean. And I mean, the working group is open. Anyone who means it seriously with the multi-signer, I strongly encourage people to come forward and to join the mailing list.
Great, thanks. I see Shuman had a comment in the chat. Shuman, do you want to just raise that so everybody can hear it in case they missed the chat?
Yeah, sure. It wasn't necessarily a question, but a comment, but yeah, I'm happy to elaborate. So this was a follow-on to Victor's questions about whether the DELEG configurations are intended to support primarily shared keys at hosted providers for many customers, or whether a more granular approach is supported. And my quick answer is, I agree with Peter's comment that it can support both, right? The syntax is amenable to supporting either shared keys or per customer or per zone keys. And the other follow-on comment I wanted to make is there are customers out there that need compartmentalized keys for security purposes, or they want to keep their own keys separated from other customers in an HSM, or they need to be able to upload their own keys into the provider. So I think all of those models need to be supported. Otherwise, the DELEG framework will be incomplete. That's it.
What can I say? You are right. Yeah, but obviously the working group, including you, is thinking about that. So I'm not worried that it couldn't work with separated keys. It's really just essentially you can imagine that it's just adding extra parameters, and then it's up to the future generations to decide what to do with the extra parameters. So we can extend it in any way possible down the road. But
Yep.
I had the impression that Victor might have some comment, or maybe am I right?
Yes, sure. So in terms of revolution or not, for me, the revolution is in fact the multi-signer support. The current designs for multi-signer, while nice for experiments, are really impossible to generalize because of the need to synchronize operators. That's just not a realistic model for general adoption broadly by all operators. Some may be willing to do it, but it's not really the way forward. So if we're ever to have multi-signer, DELEG is it. And that, in my view, is the most revolutionary thing that it offers.
Yeah, so Victor, I think, yeah, I partly agree with you. I mean, for general broad adoption, it's very difficult with the current mechanisms, right? But it is possible to deploy if you have amenable operators and kind of advanced customers, right?
Yeah, it just locks them into mutual dependence, and in terms of the corporate relationships, and the complexity is quite high. So yes, if they're willing, by all means, it's possible, but I don't see it gaining broad adoption across all the market players realistically. Some will not want to do this, and will wait for DELEG.
Sure, I agree, but I mean, there's a general need for it on a wider scale, right? Because multi-signer transitions are a mechanism that enables non-disruptive migration of a sign zone to new providers, right?
Right. So my take is when DELEG happens, that's when we'll see it being used for real, beyond early experiments in the current framework. I'm not knocking the current framework. I just don't think it'll gain as broad a traction as it needs to, and the DELEG work is necessary.
Yeah. Yeah, I think I agree with you. That's the current state, although I would suggest that you hang on until you see Johan Stensum's talk in the next portion, because he has some ideas about a more general framework.
Excuse me for cutting you off. I think we have another question in the room.
Oh, just a statement. This is Ulrich from ICANN. No, I wanted just to say that DELEG will enable us to have signers with different algorithms, and that is something that we absolutely need for multi-signer. Otherwise, multi-signer will be unfeasible for basically ever. So, because we will never be able to transition away from an algorithm. So.
One more?
David Lawrence again. The one additional comment I want to offer in support of Victor's position is that DNSSEC itself has shown not to be very compelling, unfortunately, to many DNS operators, or specifically their customers. And one of the things that DELEG is offering is an extensibility into many other services and features that could be offered through the DNS on the internet with secure pathways, And so the kind of the market power of DELEG and the DNS, it goes beyond what DNSSEC has been able to do as far as maybe leading to new killer protocol evolution or revolution on the internet, because it allows essentially resolvers and authoritative servers to know upfront that they support a modern way of looking at the DNS and in a way that has been difficult to do in the past. So I do think the multi-signer work has been terrific, and I mean, the DNS has been a tremendously successful protocol over the past 4 decades in powering the internet. And the work that Schumann and others have done on a multi-signer have been a very important part of that as well. DELEG is just looking to take it kind of into the next step where even more services can be offered.
Mark, it looks like no further questions in the room.
I'm so glad about that. So I'm now really looking forward to listening to my friends Johan Stensam's talk now as well, definitely. And that will be relatively soon at the end of the second panel. So thank you very much for everyone that's been doing the presentation so far today.